So I'm back as I have discussed yesterday that I will be talking about the area under velocity time graphs in the next video. So here I am with this next video. So I hope you remember that the last time we discussed that it's the gradient that gives you the acceleration in a velocity time graph. But there's another thing that you can calculate from the from a graph, that is being area under the curve. Now, what we mean by the area under the curve? See, if I draw a graph, okay, let's just say it is a velocity time graph, and I draw this, then this is area under the curve, the shaded region which I am mentioning. The another thing that you need to remember, that sometimes the question asks you to find out a certain quantity in a particular time interval. Likewise, from, let's just say it is from 0, 1 until 3 seconds. Motion is continued even after that or before that, but they are talking about for only these 2 seconds. So then you have to measure the area under that graph. Now the question is, what does this area is going to give me? Do remember here that here we have the speed time graph and the velocity time graph. Because we are discussing the velocity time graph, so the area under the velocity time graph will gives you displacement. What does it gives you? Displacement. But if by chance your question states that it's a speed time graph, like as instead of speed, instead of velocity, the speed is written, then the area under this graph, this whole graph, is gonna give you distance. Just remember that the area will be equals to the distance. Okay, so here, how would you be finding out the total area? Total area is being given as distance. Now, if I look over closely this structure, if I look over this structure, then this is the area which could be divided into two parts. One is a triangle, another is a rectangle, right? So here, if I look over the area of the triangle, it is half times base times height, correct? Plus the area of the rectangle, that is length times breadth, correct? Okay, that will gives me the total area under the curve, and that will gives you the displacement. Please ignore what is being written here in the PowerPoint presentation. Here the total area is going to gives you displacement if it is being a velocity time graph. If it is a speed time graph, then it will gives you distance. Okay, let's just, here we have been given a velocity time graph and we have to calculate the area. Now I can divide my velocity time graph here into three parts. One is the triangle, then my rectangle, and then it is my another rectangle, right? So here if I talk about the length times breadth, so what is this? 3, right? 4 minus 1, that is 3. And what is this? Length, this side is 5. So 5 times 3, right? If I talk about this, the bigger rectangle, it is 10 minus 4, that is 6, right? And what is this side? This side is again 5. So 5 times 6. Correct? So we have 5 times 3 comes out to be 15 meters. Correct? And 5 times 6, that comes out to be 30 meters. Then we left with the rectangle. So we have half of base. What this side is, the base, that is 3. And what is this height is? 9 minus 5, that is 4. Correct? That is 6 meters. So we have 6 meters. As the whole graph is in the positive region, so I will add up all the areas which I calculated and I'll get my answer as 51 meters. Now the next question comes up. What will happen if your velocity time graph comes under the negative region? So what you will do, you will calculate the area A1. Here I am talking about a velocity time graph. Correct? Then it is being the area A2. So what is the net displacement in that case? In that case, you do not add up the area, you will subtract the areas. So that is A1 minus A2. Now the condition is the if you have to, suppose they ask you that this is the velocity time graph, but now you have to calculate distance in that case. Now it is a dilemma. How would I calculate the distance? Because till this point I am talking to you that it is a velocity time graph. You can calculate displacement, and now I am talking calculate distance from the same graph. So what you do, just calculate the areas and add up. Okay, so that's how you can calculate the distance from a velocity time graph. Okay, Sarah is driving her car through school zone. The velocity time graph below represent her journey. Now, which velocity time graph they are talking about? This graph. I'm deleting the things from this graph. Okay, so that we can solve the question too. It says from 1 second to 4 seconds, she slows down from 9 meter per second to 5 meter per second. She is traveling from 9 meter per second to 5 meter per second. Okay, then forming a triangle. Now from 4 seconds to 10 seconds, she maintains a steady speed of 5 meter per second, forming a rectangle. Okay, here forming a rectangle. Now it says that calculate the total distance Sarah traveled during this time, first of all, and how the areas under the graph help in finding the total distance. You just add up the area, it will gives you the total distance. So that is the answer for this question. Now we'll come up, we already know that what is the distance traveled here, correct? Here because you are dividing your whole curve into the three shapes. One is a triangle, rectangle, and a bigger rectangle. If you look over here, it is 6 meters, correct? It is 30 meters, right? Okay, now in this case, the total distance traveled here, I'll just calculate the area, right? Okay, she started from here, ended up here, and then she reached here, correct? So the area, the total area I'll be calculating, correct? And that will gives me the 51 meter. Please ignore the answer here. It is 51 meters, right? Now, the next question. Please do take the screenshot of this question and solve this question as your homework. I hope you people are clear with this question. The topic, the area under the velocity time graph. Okay, let's just very quickly summarize what we have learned. We have learned the basics of the velocity time graph. Then we have learned that in the velocity time graph, it's the gradient that is going to give you the acceleration, right? Then we have learned that there is a different kinds of the motion, uniform motion, accelerated motion, and a decelerated motion. The gradient of the velocity time graph is being really useful to calculate the acceleration and to solve number of the problems. And then the next thing we learned that area under the velocity time graphs. Okay, and the area under the velocity time graph is going to give you displacement, whereas the area under the speed time graph is going to give you distance. I hope you people are clear with this explanation of the velocity time graphs. So that's all about the velocity time graphs. If you have any doubts, if you have any queries, just post your queries in the comments. I will be solving those queries. Thank you for watching. Bye-bye, and do share this video with your friends who wants to learn about the distance time graph, the speed time graphs, the velocity time graph, anyone who wants to learn about the graphs or who is been following GCSEs or IGCSEs. Okay, thank you. Bye-bye. Have a nice day.